So when we get started, John asked Tom Sharkey and I to put together a presentation on volatiles related to everything dealing with plant health and soil health. Tom and I talked about it. We're both interested in it. Neither of us are actually working in this area at this point in time. Then Tom said he's not going to be here today and wish me well. So, compliments sent to me, complaints sent to Tom. But volatiles are one of those things which are sort of intriguing, and I'm interested in plant disease diagnostics, particularly diagnostics that will get us to a solution early in the interaction, even before we start seeing visible symptoms. When plants and pathogens or plants and herbivores interact, sometimes within a matter of 30 minutes, the release of volatile chemistries that may be a signature to that kind of interaction. So those are the kinds of things we're interested, and I'm interested in eventually looking at and getting your help as we move forward. So this is sort of the interaction of everything that takes place out in the field. This is from a paper from Diaz et al. From Penn State. But basically, all these things, whether it's this giant rat or this giant herbaceous plant of a tiny tree, can essentially result in the generation of different kinds of volatiles. So the soil has microbes, it has roots, it has other interactions. Volatiles come up. The animals obviously give off all kinds of volatiles, but I'll leave that to the animal scientists in the room. Insects chewing on leaves, fungi, bacteria infecting them. We have signals moving back and forth, and all of this can result in a chemical signature based on these volatiles. The question's going to be is how do we sort all this stuff out? Now, I mentioned one of the things I do is I rot Dave's potatoes. And this is a later stage of pink rot, but this is probably the only tuber disease that I know of that I can detect by smell. It has a very unique odor that's different from any other tuber rot that I've worked with. It's not particularly pleasant, but it's very unique. And this gives me some hope that somewhere down the line we can actually begin to use volatiles under certain conditions to detect pathogens very, very early in the interaction. And early is important because that's when we need to be able to get in there and stop diseases from developing. So plants release volatiles when they're stressed. So basically pathogens do this. They have antimicrobials. They do signaling. They're not doing this just for fun. Herbivores do this. They're anti-herbivore defenses. They signal for defense. They also recruit parasitoids. So they're doing all kinds of things. And some of the chemistries, and these are for Doug Gage's benefit, since he's a former natural products chemist, these are the green leaf volatiles. So next time you mow the lawn, when that comes along, you smell things. That's what you're smelling. It's not there for your pleasure. It's there for the plant to warn other plants that something's happening. And this is methyl salicylate, or wintergreen. Plants produce this as part of their general defense responses. But this is a short collection of probably 300 or so different volatiles that I was able to find through the literature that plants can produce or the soil release during natural processes. Some of the roles they play: plant defense, antimicrobial, anti-herbivores, plant signaling. So the things that these volatiles do are tremendously important to the plant and the ecological niches that they live in. The question again is, can we use this information to do more than just study plant defense and plant protection? So they've been characterized from several diseased plants and herbivores. The different degrees of infection and damage, not surprisingly, will give you different profiles. And so early in interaction, you might see certain groups of chemicals. Later in the interaction, you may see a different set. Depending on the level of infection, you might get different sets as well. They're released early in the interactions and they're complex mixtures. So this is one of the things which I think is fascinating about this is an early detection tool. If we can sort out this mess of chemistries, tie that to what we know about plant pathogen, plant herbivore interactions, can we then use this to detect those very early stages of these interactions to come in and start managing these problems before they become really, really big? Diseases have been identified by volatiles. In apples, 3 different bacterial pathogens have been identified by GCMS and commercial electronic noses. This was done under very controlled conditions and in greenhouses, so it's not like you're out in the field, but there's some hope there. And in tomatoes that have been inoculated with the Tritis cinerea, which is a very common pathogen in both greenhouse and in the field, there are releases of terpenoids and lipoxygenase products, the green leaf volatiles is another term for those, within a few hours of inoculation. This is before you can see the pathogen. This is probably before you can even detect these things using even DNA technology. Insects, and I can't really leave these out because in case an entomologist showed up at the meeting. Similar kinds of volatiles, not totally identical. Things happen differently. So again, They're using these things as a response to the infection. Shortly after herbivory begins, within 30 minutes in some cases, there's the release of the green leaf volatiles, and later on there are other groups of chemistries that are released. These can be important for the plant, in fact, that they're using it to basically recruit parasitoids and other predators to knock out that primary insect that's feeding on them. So they're using them for benefit. If insects can detect these things, maybe we can detect them as well. In fact, there's been some success in using some of the technologies that insects use. There's some biosensors that actually detect certain kinds of volatiles. So again, can we use these to detect the nature of the attack? Soil health. Now this is something that neither Tom or I really knew anything about. We're still trying to ask my, where's Dennis? So if Dennis could define soil health, we'd be going a long way. But basically, I think what we're looking for is the kind of soil that you get maximum productivity. And you use volatiles to look at this. If you look at the soil, there are all sorts of sources of volatiles. There's microbes, both pathogens and non-pathogens. There are plant compounds being released. There's got to be geochemical reactions taking place, different soil types, different chemistries. And I found one paper that looked at about 200 compounds that are released from the soil. So it's not a simple situation. They have been used to look at some microbial community composition, so what are the different microbes there? But then it gets complicated. In one study, using barley and 2 fungal root pathogens, depending on the combination of healthy roots infected with one pathogen, infected with a different pathogen, there are 254 compounds that were identified that were being released from the soil during those interactions. Not every interaction gives you the same products, but that gives you some idea of the complexity of the situations and where the promise is there. Sorting through the chaff to get to the grain is going to be relatively important. So one of the things which is interesting about this, though, and one place where these volatiles may become important, is that some of these can be involved in biological control, not only by recruiting parasitoids, but also by changing microbial populations. Some of these can enhance plant growth, and some of these can enhance plant disease resistance. So we've got lots of things other than just detecting diseases and insect attacks that we can use volatiles as a potential indicator of the overall health of the soil and therefore the overall productivity. So some of the challenges. If we want to take this to the field, we've got to be able to have the technology to detect these things at the field scale. It looks, from some of the studies we looked at, that greenhouses might be a pretty good place because they're more confined, but in the field you've got all sorts of things going on. You just don't have one pathogen, unfortunately, coming in and causing disease for one insect, and each of these can cause different signatures. Knowing which compounds are important becomes really essential in using this kind of approach to determining pathogens. Again, something which I'm interested in is can we use volatiles to detect infection prior to visible symptoms, prior to the time when we can actually visualize these or detect them by the standard molecular technology. Even the things with some of the nanoparticles that Brad Day's working on, the sensitivity isn't quite good enough to detect something this early in interaction, but it's getting better. And then again, these early events, prior to when conventional diagnostics are useful. So the challenges, we need to have the technology. I know there's been some work done at MSU looking along these lines. GCMS is obviously something which has been used traditionally to find these things, but there have been work with certain kinds of electronic noses, biodetectors. But the important thing, at least from a production standpoint, is wherever we come out at the end of this, we have to have accurate diagnoses, regardless of the technology. That's important because if you find something, you need to be able to tell the grower what to spray or what to do, because the worst thing you can do is give them the wrong recommendation. Thank you.